Good morning. How's everyone? How many people here are here to learn more about SpEL? And how many people are here to learn more about Spinnaker? Awesome, thanks. All right, what's an expression language? Why do I need one? Is it going to make my pipelines faster? Are they going to make them stronger, more flexible? For us, using the expression language in Spinnaker allows us to kind of get information that's available when my pipeline is running and use them. So SpEL allows us to place placeholders to then get information that's going to become available to me when my pipeline actually runs. I can run this pipeline 1,000,000 times, and that branch name might be different every single time. So with SpEL, what we can do is, in that deploy stage, if it needs to know about this branch name information that only appears when I run my pipeline, I can put a placeholder, and then that deploy stage can go ahead and create a cluster based on this information that happens only when the pipeline is running. We can go a little bit further, actually. We can control the execution of our stages by using SpEL expressions. So the stages are smart enough to say, well, if this value evaluates to true, then I'm going to run, and if it doesn't, I won't. So SpEL, in the continuous delivery context, allows us to both control the way in which data flows, and also allows us to control the way in which stages and executions get performed. So in here, if somebody comes in and says, no, I don't want to run smoke tests, they're expensive, I can modify my pipeline, and I get a different pipeline based on that information that I get passed in. Let me tell you a little bit more about SpEL. So the Spring expression language, SpEL, it's an expression language, and it allows you to query and manipulate the object graph whenever things are running. It has really cool features. So you're able to add your own custom methods, and there's a lot of really interesting string templating attached to it. You might also be already using SpEL. SpEL comes in as part of the Spring framework. It's heavily used when you're kind of configuring beans and whatnot. So in here, I have an example where I have a conditional on an expression, and if that expression evaluates to false, I just won't load my bean. Timeleaves is another heavy user of the SpEL expression language. So in their templating language, you can go in and add SpEL to your tags, and magical things happen somehow. So SpEL kind of looks like this, right? I have an input box. I like to think of SpEL as input box plus plus, because basically what's happening is you're going in and you're typing an expression. That's the thing that is in between the $ curly bracket. And in the first example, in A, that cluster gets evaluated to cluster 9. You can do simple math. You can have more than one expression in your input. You can do string. So you can also access lists. So in D, that's how you reference a list. And in E, that's how you reference a map. So you can have nested maps, and then using the SpEL expression language, you can access this nested maps. This is the boring slide. Let me show you the fun slide. You can also have default values. So in A, you can say, if the value for trigger user exists, then I'm going to use that value. But if it doesn't, just default it to your favorite pop singer. You can also use filtering mechanisms. So in B, you have that question mark dot. So if I have a map, I can do this $ dot, and it's going to eliminate everything that does not match whatever's in that square bracket. You can add your own methods. So you can make up your method. And finally, you can actually put giant chunks of Java code in your expression language. So it's fun, but very verbose. When we're looking at expression languages to integrate into Spinnaker, we were really excited about SpEL, because first of all, it already integrates with the Spring ecosystem. There's not an external library I need to download. It kind of comes for free. We're already using Spring Boot and Spring Batch. The documentation seemed great. They had a lot of examples. So that was kind of the positive things about SpEL. But then we're a little hesitant as well. We couldn't find a lot of examples of using SpEL outside of Spring and Leaf. Is this language right for managing things that are not being dependencies? And are we able to customize it? And since it relies so heavily on Java, is this going to work? So let me tell you about Spinnaker pipelines. Spinnaker is our continuous delivery tool that is used at Netflix. It's the open source successor to Asgard. We build it so that you can do cloud deployments across multiple regions, multiple accounts, and even multiple clouds. Today, about 98% of the microservices deployed at Netflix are done using Spinnaker in one way or another. You can check out the website. There's a lot of great documentation. You can try it out. So from the very beginning, we designed Spinnaker to be multi-cloud available. And we work kind of very hard with the good folks at Google to make sure that Google Cloud Platform had the same level of integration than the rest of Spinnaker, than Spinnaker did with the AWS Web Service. Along the way, Kubernetes, Cloud Foundry, OpenStack, Microsoft Azure, and Titus, which is the Netflix container cloud, are all enabled by Spinnaker. So when I talk about continuous delivery pipelines, what am I talking about? What are these things? Well, when you first come to the Netflix website, you're going to see, you're going to hit all these microservices. And all these microservices are maintained by different teams within Netflix. The culture of freedom and responsibility in Netflix means that you build it, you run it, so each team will have their own custom deployment pipelines. And what they're going to do with these deployment pipelines is they're going to use them to release these pieces of software individually. By the way, if you're interested, this is done by a tool called Visceral, and that has been open sourced today. So if you want to check it out, it's probably really high up on Hacker News. But so what we're trying to do here is kind of be able to have a very secure, automated, reliable way of deploying each of these services in a way that is pretty much error-free. So what do we mean by deploying a service? When you come to AWS, what it means is I have a server group. So each one of these things with the green box next to them represents an auto-scaling group in AWS. And they just represent different versions of your software. When you release a new piece of software, what you're doing is essentially coming in and you want to release the next version of your software. So you want to release BO 246. A new version of a server group gets created. And that's what Spinnaker's pipelines are helping you to do. They're helping you to create new versions of auto-scaling groups in a nice, reliable, automated way. Now, we do this by giving you really nice cloud operations around the server group. So I can come in, and I can resize, I can disable, I can enable, I can destroy it, I can deploy, I can clone a new server group. This is the language, this is the vocabulary that you're going to use to build your continuous delivery pipeline. In the UI, all you have to do is come in, create a new pipeline, click Add Stage, and each one of these steps is available to you to customize and build. So here's an example of how disabling a server group might look like. You come in, there are a few forms that you fill out, and it guarantees that whenever your software is going through from code to cloud, each and every one of the stages are ran this way. But we also deal with clusters. So the cluster is a collection of the server groups. They might be running the same code, different versions. They might be sitting behind the same load balancer. And we also like to help you customize the process of deploying, of managing your clusters as your deployment cycle continues along. So in here, we have a shrink, scale down, disable as operations that you can do on your cluster. And this is how that operation looks like. You just have to fill out a few forms, and we take care of the rest for you. Pipelines can be fairly simple. So we take these cloud operations that I have talked about, and you can just compose them and create your own way of pushing your code to the cloud. It can be a little bit more complex. At the end here, you can see that we're starting to use those shrink cluster operations. And yeah, there might be multiple deployments in your pipeline, or they can be a little bit more complex. So let me talk about wiring up the expression language into the Spinnaker pipelines. One thing to keep in mind here is that everything that I'm going to talk about is available in GitHub, open source. So if you feel fairly sardonic, you can go in and enter that search term, and it'll give you, it's only 7 classes that are affected that really deploy this functionality. It's very small, but we found it to be fairly powerful and fairly easy to use within Spinnaker pipelines. So why an expression language? Like, where did this need come from? For us, it actually came about when we were trying to integrate different Jenkins stages into our Spinnaker pipeline. So Jenkins is great. It's a very good tool to kind of build packages, and it's a great test runner. And so in a lot of our pipelines, what we have is kind of scenarios like this, where you have Jenkins triggering your build, and then we pass it on to the Spinnaker cloud native operations that are going to be very good at kind of pushing code into the cloud, creating ASGs, and then we might pass the operation back to Jenkins, and then onto Spinnaker again, and then back to Jenkins. This is how configuring a Jenkins stage looks like. And what we wanted to do here was be able to go into your job parameters and very easily kind of apply one of these expressions, be able to reference values that are perhaps in my context that are available when this pipeline is executing, and really like put a placeholder there. So the first thing that we had to do was we had to, we customize what's called the parser context in SpEL. And that just allows you to change the way that you want your expressions to look like. So by default, there's a pound square bracket, and you can use this parser context to kind of change the way that you want your SpEL expression to look like. The second piece of the puzzle is kind of this task context that we have in Spinnaker. So that Jenkins stage, when it runs, behind the scenes, it has kind of this in-memory thing called a context, which is just a map of information. As different tasks run, and this task runs, and this task runs, this context is progressively updated. Now, this is the information that your expression is going to use when it's trying to resolve variables. So when I'm going to, so the way that the string expression that I'm going to type it in my Jenkins field is going to be changed into another string, basically goes like this. I enter a SpEL expression. It goes through parser context to detect the expression itself, and then it runs through the evaluation context, and then it gives you a result. And so what we're doing here is, before we pass the information to Jenkins, we just intercept it, right? We just say, of all these fields that I'm passing into this REST API, are there any context variables in here? And if they are, we just use this very powerful expression language to replace it into a string, and what we pass to Jenkins then is just that variable. So at this point, what we've done is we added the ability to go and say, I want $job as a parameter that I'm passing to Jenkins, and it's going to resolve to my favorite job name, which in this case is Fairly Godmother. So you have a question?
Yeah, the reason inside string expression language you modify the pound to the $sign is because variables from Jenkins are coming in as $sign, is that right?
So the question that you have is, the reason that I modified the variable from pound to a $sign, is it because the variables from Jenkins are coming in as a $sign? So the original decision for that, and probably turned out to be not the greatest one, was that if this expression failed to evaluate, it was going to send that $sign expression to Jenkins, and because that was the scope of our integration, Jenkins uses that $sign in its parameters. So it's kind of like that last hope effort that, well, if we can resolve it, Jenkins will.
Oh, I see.
Yeah.
So the last scope is I see.
Yeah. Does that answer your question?
Yes.
Excellent. So This is great, but what if I want to create my own custom variables? The thing about Spinnaker is that behind the scenes, there's a lot of kind of interesting variables. And what I wanted to do is just be able to extend the list of variables so that it's not just a context variable, but I can plug in to the execution context of that pipeline. I can plug into kind of the information that is available to my running pipeline. It's just a map. We can just go in, and before we pass it into the context processor, we can just say, well, if the trigger has parameters, let's just alias it to parameters. And we can create as many properties as we want. And this shows kind of the power of extending an expression language, right? Because you can then have the vocabulary and have aliases to things that you feel are important in your continuous delivery pipeline. So for us, we only have a couple handfuls of them, but we definitely create aliases for the execution, parameters, and trigger. And we also, the one that is fairly interesting, the last one is deployed server group. So I have a deploy stage. I want to be able to pass in the name of that cluster that I created into the smoke test. So we just give you a shortcut. And you can say, give me the deploy server group, the name of the deploy server group in US East 1, and pass that as a parameter to my Jenkins job. So being able to customize these properties allows people to really quickly and very easily kind of resolve the values that are happening to the pipeline when it's running. Another thing that you can do is just add your own methods. So it looks like this. I have a method, and then in my evaluation context, I can just come in and register my own methods. So then anytime that anybody enters a pound expression, they're going to resolve to that method. A few examples of methods that we have available to the Spring expression language in Spinnaker are things like alphanumerical, which is takes all the non-alphanumerical characters and strips them out. We have interesting kind of things to get information from other places. And we have converters, right? So normally, if I have a map within Spinnaker and I want to make sure that that's converted to a proper JSON file so my Jenkins job can parse it, I can pass it to the toJSON method, and then it'll do that data conversion for me. So one example of this is if I do alphanumerical, my favorite string, is going to remove all the spaces, and the result that is going to be passed into Jenkins is going to be whatever it gets evaluated to. Now, I'm going to talk, right now we have this Jenkins stage and we're passing data into that Jenkins stage. How do we get data out of the Jenkins stage? So for that, we use a mechanism called properties file. What happens is a Jenkins job finishes, it creates a property file that gets archived. The property file has different fields. And because in our SpEL, we're able to access variables within the pipeline, we can come in and reference that. And the mechanism that we built into Spinnaker was then we would go to Jenkins, we would pull that file, pull the contents of that file, and make all the variables accessible. So when I'm creating a trigger, I can specify a property file, and then I can reference that by just trigger properties and then the name of my variable. Individual stages can also produce property files. And then when you're configuring the stage, you can just set that property file. And then that would be available to you as either a variable in the context. Remember that context that I talked about before? You have this thing that is running and is constantly updating this map in memory about the values it cares about. That value from the property file makes it to the context, but we have a helper method so that if you want to be fairly specific about where you're getting this property file, you can use the stage helper, you can give it a name, and you can say, give me that variable that I care about. So let me just give you an example of how that looks like. I have a trigger. It has a property file called blab properties. And then I am taking that variable and I'm passing it into the later Jenkins job and I'm converting it. I'm doing the alphanumerical transformation here and then I'm making it uppercase. So when I run this in Spinnaker, it kind of looks like this. You can see that I have my different stages. Run it. I can pick any build I want. I can see that the parameter that I specified is now in uppercase, and all the other characters have been removed, I can see that is the parameter that is being passed into Jenkins. And I can click there to go in and see the original trigger and see that that was the actual file that was being ran. Yes?
I don't know what variables are available to you at each stage.
So there's a mechanism in Spinnaker where you're able to look at the execution. That's kind of the way that we cheat. So there's a known set of properties for each stage, right? And if you're inserting this dynamically, then what usually happens is people would run their execution to a certain stage, and then they would just look at that JSON file that underlies the original value, and then anything in that JSON file is valid to be used for a later stage.
Look at Jenkins, see the properties file there, and then.
So normally what people do is they set up their property files very purposely for Spinnaker. The way that the parameters work is they allow you to kind of build this kind of black box, this multi-use stage. So then you just manipulate that, knowing that you're sending properties in, you're getting properties back, and the properties are of a certain name. So now that we can do this in Jenkins, can we do it everywhere else? In our deploy stage, what we want to do, so the need for this came about because there was a team, and what they were really interested in doing was developer branches. So somebody comes in and they checks in their code, and I want to create a cluster on that. So their QA can go in, look at it, click around, see if everything is okay. But what they wanted to do was really name the cluster after the branch in Git. So the way that we are able to manage that was the Spinnaker deploy stage takes a bunch of fields. One of these fields is the stack. And so basically what we're saying is, give me the branch name in the trigger, and then when you're creating that server group, do that. So by enabling SpEL expressions in every field available in Spinnaker, what we're able to do is add that power of, here's a field, I might want to give it a default. I might have values that I don't know about. I might want to get a URL from an external source, and I want to use that in that particular stage when it runs. So looking at here, that first build, 1153, had a different branch name than build 1151, and you can see that it created two different clusters. To do that, all we needed to do was pipelines come in as a JSON declaration. We take that JSON, we convert that into stages, and then when the execution of a pipeline happens, there are different tasks, and each task will have, again, that stage context. So all we needed, I'm sorry? It is versioned in the backend service. We don't expose that. So anytime that you modify your pipeline configuration, we store a copy of it if you're using S3. So what's happening here is that original JSON declaration might generate external stages. We come in and we evaluate that entire JSON to see if there are expressions that we can resolve at the beginning of the pipeline. And then later on, when people are asking for values within the task, we also pass every one of the values to this SpEL expression processor, so that then if you enter anything in any fields as SpEL, it comes back to you as a string or whatever can be evaluated. And the thing that we had to do here really was just add the ability to SpEL to kind of come in and convert all the maps and all the lists, go in and see all the keys and all the fields and make that into parameter processors. And this becomes very powerful, right? Because if you think about the original cloud operations that you had, now you're able to come in and add, for example, the name of the cluster into the pipeline, but doing that kind of in that properties file that you're having in Jenkins. So you're now able to grab a value from anywhere and shove it into your pipeline execution. It makes it very flexible, and what we've seen is it helps kind of address a lot of, I have this data, I want it in a certain format, or I have this data, I want to convert it into something else. And most of our teams use this extensively. But it's kind of annoying to have to come in and kind of create a JSON file and output properties. So in the same way that you can specify job parameters in Jenkins, you can specify job parameters in Spinnaker. And so you come in, there's a click and point interface where you can come in and you can add different parameters. And then when you run your pipeline, you can have, so you can see there, it's asking me, do I want to run a wait stage? I provided a few options to that wait stage. There's a time to wait variable, so you can provide that. And the syntax that we chose for addressing properties is the same as the SpEL expressions. So now I have the stage, for example, that is going to tag an image with certain values, and then I can just add keys into it. So the values that are going to be there are going to be the ones that I give the pipeline when it starts up. So we're at a point where we have Spinnaker stages that are able to get properties evaluated at every point. I'm going to talk to you now about how we use SpEL expressions and that idea of that format to then control the execution of stages in the pipeline. So the way that this works is every stage in Spinnaker has this little checkbox in the bottom. You take that checkbox and you say, if this expression evaluates to true, run the stage, and if it evaluates to false, then skip it. Where it can become very powerful is when you start using this as a combination, as something that is not just on one stage, but as something that is in multiple stages. So we have a team that wanted to do A/B tests, and this is how their pipeline configuration looks like. There are 12 cells of tests, and each one is parameterized. So when they run that pipeline, they say, here are some of the variables that I care about. And each of those stages in that pipeline that I showed you before are kind of configured to be on and off and on and off depending on the evaluation of a certain expression. So when I run that pipeline, I can see that only cell 2 and cell 1 have run based on the input that we're giving. So that provides a pretty cool way to kind of have all your possible stages and then really just kind of run the ones that you care about. The other way in which you can control the execution of your stages is through what we call a manual judgment. So Spinnaker has this notion of manual judgment. It's originally built so that you can have certain gates and checks that your pipeline is executing. Do you want to continue at this point? Somebody from the open source community contributed the ability to then choose an option of what you want to do when you're giving that approval process. So what's happening here is your pipeline runs, hits that manual judgment step, you'll get an email or SMS that says, hey, this requires notification. Click on that link, you come back, and then you choose what you want to do next. And the SpEL expression that we have for there is, if the judgment is run more tests, run this stage, otherwise don't run this stage. So on the running of the pipeline, we have a stage that allows you to then configure what you want to do with that. The manual judgment stage itself looks like this. You come in, you got a drop down, you have your options, you select one. And in here, if I say, I don't want to run more tests, I want to deploy right away, you can see that when the pipeline runs, more testing stage gets skipped. I'm sorry? How do you update the manual judgment? So what's going to happen is when your pipeline executes, there's a pipeline execution view for that individual execution. And the manual judgment stage is going to just kind of have that dialog box that I check kind of where you see that task status is going to be in there. So then you can click on yes or no. And if it times out, you can control how you want it to continue. I'm sorry, could you speak up?
Yeah, what I'm saying is, if it sends the alert, right? If it sends the alert to email,
Yes.
and if I take action on that alert,
Yes.
will that, action goes back to continuous pipeline?
So the notification that you get is just a link back to your execution.
Yeah.
And the person that is going to decide whether they want to continue or not is, so the thing to notice first is that you specify who it notifies, and then you get like a Slack alert or something that says this is ready for manual judgment. You click on that, you go back to Spinnaker, and you continue in the next phase. Yeah. So what you're doing here is you're essentially controlling that flow of execution based on decisions made on, like your promotion process. So the last thing that we have is this check for precondition stage. And the way that this works is it's going to gate an entire branch of execution in your pipeline. I can come in, I can add several expressions here, and then if they evaluate to true, then the pipeline continues, and if it doesn't, all the subsequent stages get skipped. So it looks like this. I come in, if the precondition stage evaluates to true, my entire pipeline runs, and if it evaluates to false, then that branch of execution is stopped, and all the subsequent stages are also stopped. So by using the Spring expression language within Spinnaker, we're able to kind of have these really nice interfaces to control how and which parts of our pipelines run. So when you're configuring this expression language, there's this conflict, right? I have UI elements that are drop-downs, that are checkboxes, that are text fields. How do I make sure that I'm able to come in and really enter my expressions in the places that I need it? So in the Spinnaker UI, we try to help you out as much as we can. The first part is really documentation. We realize that having good documentation helps people use a lot of these things, especially when a lot of it is not very obvious. So we started off with this really crappy Google Docs, but people were kind of like found it useful. And then when we open source, we created this document, which is a pipeline expression guide. And what happens is, if I'm coming in Spinnaker and I'm typing an expression, when it detects that it's an expression, it's going to give me a link to the docs. So at least I know what I'm messing up. The next thing that we try to do is kind of allow you to toggle different fields. So in the wait stage, when you're trying to enter an expression, you can just click this button, and now you can enter this test field. And in places that have drop-downs, we have a simple input field, and then when you click on that toggle list of clusters, you end up with a drop-down. The nuclear option, of course, is always, when you're editing a pipeline, there's a way to edit the JSON, so you can just come in and put your SpEL expression wherever your heart desires. So at Netflix, we have this culture of freedom and responsibility. You build it, you run it, and when you're building tools like this, you're also supporting it. So what we have is we set up a Spinnaker Slack channel to help people that have questions around their execution of Spinnaker. When we're trying to get people migrated into pipelines, we had set up office hours, and at any time you can come in and ask for one-on-one for help with a first responder. This has been incredibly useful in kind of improving the platform, as well as kind of figuring out what is the next thing that we build. And some of the errors that people see also kind of arise when you're trying to help people out. So some of the common errors around SpEL are you come in and you have a double nested $sign. Other problems are, for example, you have a parameter that has several spaces in it, and then that first option doesn't really work because it's just going to try to evaluate differently. So we always recommend people using the square brackets. The one that is really subtle is that SpEL has this really bad habit of kind of requiring you to use #root in a lot of places, especially inside of methods and inside of filters. So that first expression, even though it looks correct, won't work. You need to add that #root in order for your expression to evaluate correctly. And that's probably one of those bad design things inside of SpEL that I wish I could change, but it's something that we encounter a lot. Here's a fun one. When you have multiple expressions in one command and one of them fails, the entire execution is going to fail, so sometimes you end up debugging the wrong expression. And then I don't want this to be evaluated an expression, so this is a really hacky trick for you to just say, I want this to go in and evaluate in Jenkins. I don't want Spinnaker to do anything for me. So you just send a string, and it gets evaluated, but it's the string that you want. I'm not very proud of that. One thing that kind of integrating SpEL into Spinnaker has allowed us to do was kind of look for common patterns in pipelines and then find to see if we can kind of make them better through SpEL. So one of the common patterns that we kept seeing was people would have a stage that runs, then they would have a Jenkins stage that all it would do is go in and fetch a remote URL, get that value, and then pass it into the stage. We solved that by just being able to come in and say, well, just in this property, just get that JSON from that URL. So we're able to kind of just start plugging in values into our pipeline from strange places from the internet. One example here is somebody would want to come and get a fast property value. That's the first one. And that second one there is I'm running a canary analysis. I want to only run this when my build numbers are different. So if the thing that I have deployed in production is different than the thing that I have running locally, we can access the Spinnaker API, and that resolves the value, and then we can do this comparison here. What we found here is that using expressions can be a really nice temporary solution to problems that people have as well. So when you start a pipeline in Spinnaker, for example, you can come in and you can say, I want you to send me a notification when this pipeline completes or when this pipeline fails. The question that people often ask is, can I just have an email sent to the person who started this pipeline? And our kind of solution was, well, you could create a template for the person that it sends. So if I come in and I start my pipeline, I can ask if that trigger that user is set. So if somebody has manually started that pipeline and my pipeline fails, an email will be sent out to that person. But if this pipeline is being started automatically by a Jenkins, for example, then just email the whole team. That's great, but it didn't work for a lot of people. So then we ended up building something that was kind of a little bit more robust, which is basically when you start a manual execution of a pipeline, you can check, notify me here, and then there's a nice UI for it. So I guess what I'm trying to get to is pipelines sometimes are, expressions sometimes are not the right answer, but kind of they can work there as a good temporary stopgap for really any kind of weird problem that you have in your pipeline configuration. Here's some things we like to do with pipeline expressions to make them better. Building them, debugging them, constructing them is fairly crappy right now. So we like to be able to have a better tool to support you kind of crafting your pipeline and pointing them to things on the fly. We're thinking of better helper methods and have a better support in the UI in Spinnaker for this kind of functionality. So what are the results? We introduce SpEL expressions everywhere. They kind of become the kind of standard way for you to say, I have this value, I wanted to fill it in. It's the kind of mañana way of doing things, where you can say, I know something is going to fill this value in. Well, of 5,000 pipelines that we have currently running in production, more than 1,000 pipelines use the SpEL expression in one way or another. So the SpEL expressions have solved their problems in a certain way. We find that having the power of this expression language into your Spinnaker pipelines really gives you that little I am going to segregate this little piece of programming logic, and that is the only thing that is going to get evaluated, and it keeps the rest of your deployment pipeline fairly stable. So it works pretty well for us. So I hope you enjoy this presentation. I would encourage you to try out Spinnaker, and if you're looking for building things like this, we're always hiring, so come talk to us. And I'm wondering if anybody has any questions. Sure.
As you're using a Spinnaker to build a production pipeline, right? So you must be running your deployment validation phase, your feature phase, your engineering phase. So I guess using SpEL to build all those phases, or using other alternatives to wire up with the Spinnaker.
I'm sorry, can you repeat the question?
So the question is, when you build these automated pipelines all the way to production, right?
Sure.
So at different stages, you have to run your deployment validation tests, your feature tests, your end-to-end tests.
Yes.
Are you using SpEL to build those tests, or any other like tool?
SpEL is just a tool, right? Like if you know the value ahead of time, you can just enter it, right? The places where you found useful is if you're running smoke test, for example, and you don't know what the cluster name is, you can use SpEL to fill in that gap. But you know, your test configuration might be different depending on which team you are and how that's set up. And you know, some teams use external tools. So we have, for example, in Spinnaker, there's a canary stage that takes a lot of the best practices on running automated canary analysis. And that doesn't require a SpEL expression because there's a stage that we build that takes all the best practices and integrates it into your pipeline. So SpEL is useful in certain places, but not in all.
The reason I'm asking the question is, most of the enterprise organizations, they're using industry standard tools such as like CDM or they're using C#, Java, Python, or
Sure.
so those kind of tools, right? So is there any way we can write up those tools with Spinnaker and pass the test results back to like your Jenkins or TeamCity or VFS?
I'm sorry, I don't think I understand your question.
So I think so Jenkins runs all of this.
Yeah, okay.
So there's no like Spinnaker runner for running a script, for example. All that stuff gets pushed to Jenkins, and then you can parameterize the Jenkins job from Spinnaker parameters, which can be done in SpEL.
Anybody else?
Is this more tied into Jenkins only, or is there any other integration?
So the question is, are we really tied to Jenkins? So Spinnaker, the strongest support that you have in Spinnaker today is Jenkins. The open source community has contributed integrations with both Travis CI, and I believe that somebody's working on a TeamCity integration. In terms of triggers, you can fire off a pipeline based off a Jenkins build, but you can also fire up a pipeline based on Git. So a Git push would trigger one of those. You can fire up a pipeline of a Docker image being pushed to a registry. You can set a cron job, for example. And then in terms of integrations, you know, like your Jenkins can really code anything. So if you really needed to, let's say, call out to a specialized system, the recommended approach is to use something that, something else that is able to do that. Adding the stages is not very difficult. In fact, the Travis CI integration was contributed completely by an external company called Shipstead. Yes?
How do you verify that your SpEL expressions are correct? Do you have like something that detects syntax errors or anything, or is it just trial and error mostly?
It's mostly trial and error. There is a super hacky approach in that there's a comment field in most of the stages, so you can just progressively build out your SpEL until it fails. And that's what we're trying to address with kind of the better tooling for the future, to be able to say, because a lot of these values are available to you only when you're running in, like when your pipeline is actually executing and doing something. So what we want to build is really kind of like point to this pipeline, point to this stage, and try to figure out what that expression would evaluate at if you put it there.
Can you customize the triggers? Like, what triggers the pipeline? Can I come up with a C# or Node.js application or what kind of trigger?
Sure. You can also, so Spinnaker has a full API underneath. If you go to the UI, a lot of the individual tasks are run. Pipelines can be triggered off the UI. You can have ad hoc pipelines. So, like that's one way of integrating it. And then another way of integrating it is that the listener has the ability to reflect to webhooks. So you could then add a webhook to kind of trigger off your pipeline or whatnot.
Does it provide an API?
Yes. So there's a full REST API underneath every operation in Spinnaker.
So you have 5,000 pipelines.
Sure.
I assume they're all not running on Spinnaker.
There's not one Spinnaker service because they're microservices. So we run two Spinnakers, and the reason that we run two Spinnakers is more for PCI compliance purposes. But yes, we have one Spinnaker at Netflix managing all our accounts and running all of these pipelines.
Is there
it's just a JSON file. Like I can just go in, click the edit as JSON, copy and paste, I'm done.
Or just read from one API and post to the other.
Yeah. Anybody else? Yeah.
This question was more or less asked, but with so many pipelines, how can you version them and keep control of who edited what at what point in time?
So what we find is that, remember that everything in Spinnaker is scoped to an application, right? So we try to do our best to kind of make the deployment of a service group scope to one application. So normally you probably just get like 4 or 5 people working on the same application. I don't know if the answer makes sense, but like you don't get a global view of every single pipeline. You get all the pipelines that are related to your application. And most of the teams that we see probably have 1 or 2 people that are actually dealing with the pipeline, and everybody else in their team are just kind of running them. Like to them, deploy to prod is just a button. It's not an entire pipeline that is involved there. All the requests get logged in S3, and I think one of our like outstanding technical debts is really kind of change the way in which pipelines are saved so the user gets tracked. And that's just been kind of long-hanging fruit that hasn't been addressed.
Would it be right to say there would be at least one pipeline from microservice?
I'm sorry?
There would be at least one pipeline from microservice.
Well, it depends on what you're building, right? Some teams decide not to use the pipeline mechanism, and that's fine. We have a full API that they can use. Other teams don't use pipelines. They push from something like Jenkins, calling the Spinnaker API, because it hides cloud accounts and secrets and that kind of stuff fairly well. And going back again, you have this cloud native operations that you're able to use. So, but yeah, most people would have probably, I would say, probably 3 pipelines. You would have kind of the bake and deploy to test, and then that promote to production pipeline. And like some people would have maybe a canary pipeline in between. And other teams, like the pipelines are generated programmatically from command line tools and so forth. Great, thank you very much.